Okay, thanks everybody for joining us for part 2 of our webinar series, The True Story of a Data Science Project. This episode is called Needle in a Haystack. It's about exploratory data analysis. As you know, Dr. Data Science broadcasts the third Wednesday of each month. And we cover this year a different phase of a data science project. Last month, if you want to go to our YouTube channel to check out the prior recordings, you can see an introduction to this project and exactly what it's about. I'll give a brief summary of that in a second. This session, as I said, we're going to be covering exploratory data analysis. Let me give a brief sort of setting of the scene. The project is about wafers of die or chips, memory chips, let's say. And the point is to analyze the wafer maps. Wafer maps are the sort of little blobs that you see over on the right there that give a visual indication of the tests that pass or fail as the wafer goes through the manufacturing process. And the ultimate goal of this project is to hunt down bad wafers. Those have big orange or red splotches on them, the ring of fire or the donut pattern or whatever it might be. We want to identify those from the thousands of wafers, the millions of tests, and do a root cause analysis from the sensors throughout the factory. Ultimately, we want to hunt these down, find out why they're happening. And it's a massive quantity of data, complex data, and we're going to have to use some pretty advanced methods to do that. And that's what we're going to be investigating through this. The current status of this project is still ongoing. We have a series of complex transformations and iterative modeling, making pretty accurate predictions, which we're using in production sites around the world for TIBCO clients in high-tech manufacturing. And we're even beginning to apply some of these methods to other verticals, from genomics to retail analytics. So let's talk about exploratory data analysis. And this is the actual data analysis that we did. And you're going to see that it's a combination of basic Python stats and some basic visualizations, a few more advanced methods. But then what I want to do is to take a step back and invite Neil Kanungo, who's our special guest here from Dr. Spotfire. This is our first crossover episode. Feels like an episode of Knots Landing. Well, maybe that's dating me a little bit, but crossover episode from Dr. Spotfire, where Neil is going to talk to us about how you can do exploratory data analysis in Spotfire. Hopefully you'll be able to see this sort of contrasting approach between the more code-oriented and then the more visual sort of WYSIWYG, if you like, approach that Neil's going to show us. So let me just walk through what we actually did in this project. We got the raw wafer map data, and we just want to get to know the structure of that. Obviously, the first thing you do is look at the data set itself. Here we've got a bunch of wafers. We're just seeing one wafer here, 1-1. And then each of those wafer maps really represents an XY pattern. You're plotting XY points in a disk. And you're actually doing that for multiple parameters. So every time we look at one of these wafer maps, these splotchy patterns, we're just looking at one particular parameter. So we might be looking, for example, at parameter 1543, and then we look at the 14,5 XY value and the 15,5 and so on, and we plot those on a screen and we see those heat maps. That's basically what the meaning of this data set is. Now, if we want to just get to know the data set as it is, Pandas describe is a perfectly good way of profiling your data set. It shows summary statistics, means and standard deviations and quartiles and so on. Note the empty columns, by the way. You'll see, like in param 3, the mean, standard deviation are all null. That probably indicates the column itself is entirely null. Also notice the wide variation in the numerical ranges, something that we're probably going to want to normalize if we're comparing one parameter to another. Here we're going to just focus on a single wafer, and notice the empty column param 3 that we saw in the summary statistics. We're verifying here that it really does seem to contain only null values. And there may be lots of those, some of these other parameters, and we're probably going to want to get rid of those. Another thing we might want to do is to look at correlations. We've got so many different parameters. Maybe there are a whole bunch of parameters we don't need to look at because they're highly correlated with all the others, and we can just sort of group them together. If we do this, this plot here with matplotlib, where we're showing correlations with between parameters, you can see these yellow marks indicating, before 200 and between like 350 and 450. They're very correlated with each other, likely redundant columns that we can actually get rid of and reduce the complexity of the problem. So we remove the purely null columns, and we remove those that are highly correlated with each other. And now we're just going to focus on one parameter, one wafer. I've mentioned in previous episodes from one of my favorite data scientists, Peter Shaw, who we had here last year. And one of the techniques that he used is the one observation approach, where you really just focus down on a single observation, in this case, one parameter, one wafer. And we take a look at that. We notice again, there are these null values. We'll come back to that in a second. And immediately what occurs to me when I look at this is that I kind of want to pivot this so that I can visualize an entire vector of sort of X, Y values and drill into that. This is really what I want to view. For each wafer, for each parameter, I want a sort of plot of those X, Y values. And so the next part of manipulating my data is to transform that. We filter to a single parameter. You can see from the Python code filtering down there, grouping by the wafer ID, we create this array of values and convert that to tabular form. So it's now a single row per observation, per wafer, per parameter. And then we're actually going to normalize that as well for the reason that I mentioned earlier. And so now we can view it. And we immediately see those gray splotches, which Spotfire we're using to visualize this with its wafer map visualization capability. The sort of special case of its sort of geospatial features. And we see those gray areas are going to be a problem for some of the analytics techniques that we want to use. Treatment of null values is often a huge headache. We're going to come back to that time and time again. We're actually going to devote a lot of some sessions to it. And it's something that we need to discuss and apply various analytical techniques. But for now, we're just going to fill that with zeros. And then we can now start visualizing these wafers properly. Now, what we want to do is to look at thousands of wafers at a time coming in off the lots. And that's way too much for a human being to do. So we begin to see some common patterns here. How do we group those together across these thousands of wafers? I'll come back to that a little bit later. That's a more advanced exploration technique. But now I want to switch gears a little bit and hand over to Neil. And Neil, you've seen some of the stuff that I'm doing here with exploring my data set. How can we do that in the world of Spotfire? How can we do that in a way that doesn't require manipulating tons of Python code and sort of scratching our heads about how the best way is to do that, something that's more visual?
Yeah, thanks, Stephen. Yeah, I really like to use Spotfire for this. I really like to use visual tools for exploring the data. It's a little more immersive. It can be a lot of fun, and it's a lot less coding. So I thought I'd show you some of my process today and a little examples here. So let me move this out of the way. So today, yeah, I wanted to talk about using Spotfire for exploratory data analysis, and like I said, the visual aspects of it. So here, I was going to start with this vehicle data set where I have this data set of both categorical and numerical values for different vehicles, and you can see all of these rows here. And the way this is typically oriented with tabular data is your columns are also called dimensions or variables, and then your rows are called records or measures or observations. So each record here, each row here is a measure or is an observation of a certain variable. And I want to start to explore different trends and patterns in this. And so some of the things I'm going to talk about are when we look at these values, how do we look at the distributions of the values? How do we look at the typical values and usual values? How do we handle those missing values that you mentioned, Stephen? Covariation patterns, things like that. And with Spotfire, it's really nice because you have this whole flyout where you have every variable in your data set, every column, and you can select it, and you can select, for instance, a column here. And if you go to the settings, it'll give you a little summary here of, the minimum, the maximum value, average, median. So this is starting to give me a sense of what the values are. I can see that there's a very discrete number of gears here.
So it already knows the data type, what type of variable this is, so it knows what to display to you, right?
Yeah, exactly. It's noticing that this is a numerical data type, the number of gears. But if I go down here to categories, for instance, and I look at, let's say, like the car line,
Mm.
these are the different car lines. It's saying, okay, well, this is a categorical type. There's 520 unique counts, or unique values in there. And this can be useful if I have, let's say, a binary data type, and I'm, something that's like yes or no, or something that's maybe I have three categories like vanilla, chocolate, strawberry, ice cream. And I see my unique count has, 6 or 7 here. I might know that there's something wrong with my data. Either there's a category I'm not expecting, or maybe there's a typo or something in some of my data. And you can look at the actual unique values here. So let's say I found that I wanted to make R8 here. I wanted to make that all R8 spider. I wanted to group that together. I could just make that R8 spider right here, and that's going to apply that, and it's going to group them together. So it's going to replace all the R8s there, and it's all automatically going to log that as well into my data canvas, which is my data flow workflow. And so you can see here's a previous value, the new value, and there's also a wealth of transformations. You had mentioned, Stephen, pivots. There's pivots and unpivots, normalization. You can put R and Python code directly in here if you want to do any other transforms. And you also have a full expression editor in here as well, where you can actually let's see, a full expression editor if you want to do other sophisticated transforms with the Spotfire expression language. So that's just kind of like the first kind of cursory overview of okay, what's in my column. And I can go to this little light bulb here, and it's creating a frequency chart, so I can see the car line here. There is so this is oops, sorry, I think I had the number of gears selected. So this is the different car lines. If I wanted something maybe a little more useful than looking at car lines, I think something like the transmission type might be more useful here. So if I want to
I see.
see the frequency of transmission types of all the vehicles, automatic, semi-automatic, so we can see most of the vehicles in this data set are automatic.
And that's often the first thing I want to do after I've sort of profiled my data set is just frequency of categorical variables, histograms of numerical variables.
Right, right. And with the numerical variables right here, you can get the histogram. You can also just, when you're looking at this overview of kind of summary table here, you can actually just click these and add these
Oh, I see.
directly
Yeah.
in. Yeah. And so, for city fuel efficiency, there's this very continuous type. It's automatically binning it for me. I can also turn off the binning if
Mm.
I want. So,
Oh, great.
starting to get a sense of the distribution of this data here. Also wanted to mention the summary table, which looks at all of the numerical variables. So you can just click summary table, and this looks at all the numerical variables and shows you a statistical summary of average, min, max, median. So this is a very quick way to kind of get started, and things I'm looking for. I didn't I want to make sure I communicate. Okay, I see visualizations, but what do I do with this information? So some things I'm looking for are, again, typical values. I think a great example is the number of gears. So we see here with number of gears that, let me move this over here, and I'll show categorical. We see that it's typically, 6 gears on a vehicle. We're also looking at modality. So, does the distribution have one peak? Is it one mode? Is it normally distributed, or is it bimodal with two peaks, multimodal with multiple peaks, or uniform? So, I know that the number of batteries data is more uniform. All the cars have one battery in this data set.
Hmm.
So, those are some things I'm looking at. Some other stuff I want to look at are measures of center. So
Mm.
I think this is really important because if your data has a lot more values on the right, which is called a right skew distribution, or a lot more values on the left, a left skew distribution, that might change the measure of center. So you can see that the mean or the average here is moved over to the left on the left skew distribution because of some of the more extreme values here. But the median might be a better measure of center. And so I can use Spotfire. I've overlaid here one standard deviation, plus or minus one standard deviation, the average and the median. And I can use this to try and evaluate how normally distributed my data is. And this curve you're seeing is a Gaussian distribution. So I've added this in the lines and curves. You can add, Gaussian curve fit. I have median, average, plus or minus one standard deviation. So there's lots of different reference lines I can add here. And so, I'm looking for normality in my data. This might affect what I do with my data later.
Sure.
What type of the way my data is distributed might affect the statistical methods I use to analyze it. And I think this is one area where we can often see people messing up because a lot of approaches out there are based on the assumption of normal data, normally distributed data, but the data is not always normally distributed, and that can cause inaccuracies in your results.
Yeah, or you may be using a model type that demands a certain type of distribution, and therefore you want to transform it in some way.
Right, right. Yeah, so that's why I'm showing some other different distributions here that you can transform your distribution into other distributions. If you're using, for instance, a gamma distribution in your approach, then you could transform it into that. And so this is a way that I'm starting to look at this, and I looked across a lot of this data, and I found that a lot of it, get the average and median very close together. A lot of it was pretty normally distributed, which is good. Because the next thing I wanted to show is how to use some data relationships tools. So now, we did some visual high level exploratory analysis, but how do we go a little bit further into this and use some actual statistical tools? So Spotfire has some EDA tools built in. So I like using this data relationships whenever I don't know anything about the data set. I use this data relationships, which can do a pairwise comparison of all my variables. And what you see here is linear regression, Spearman R, and a few others. It says numerical versus numerical if I'm comparing two numerical values pairwise. And then you have numerical versus categorical and chi-squared, categorical versus categorical. And you see Spearman R, that's for non-normally distributed data, or non-parametric distributions. And you see linear regression for normal distributions and parametric distributions. ANOVA's for parametric and Kruskal-Wallis is for non-parametric. So knowing, again, the distribution that I have of my variables is useful now when I'm going to use this linear regression method to find data relationships. So I'm going to look in terms of city fuel efficiency, and I'm just going to compare all the other numerical variables. I'm going to hit OK, and Spotfire automatically calculates this data relationships table for me. So if I resize the columns here, you can see that this is showing my p-value for significance, it's showing my r-squared for correlation. And so it's together forming the strongest relationship between any two variables, or more specifically, city fuel efficiency in another variable. And so rather than me going through and manually creating multiple pairwise comparisons, this is doing them all for me and telling me which are the most highly related, which is highway fuel efficiency, as we kind of expect to see. The next is engine displacement, and I think that's kind of also what I would expect to see. So larger engines, which are on this end of the chart, have lower fuel efficiency, and that makes sense. Smaller engines have better fuel efficiency. When I look at cylinders, the vehicles with more cylinders, typically sports cars and things like that, tend to have worse city fuel efficiency. And number of gears. So now we're seeing that the vehicles with more gears also have lower fuel efficiency. But we're starting to see that this line is getting flatter, and my r-squared is dropping. So the correlation's dropping. As I go down on this list, you start to see this becomes more of a data cloud, and there's not really a relationship. We start to lose relationship of the variables. So
this is useful if I'm doing some sort of predictive modeling. I want to figure out which variables to include, or maybe exclude if they're too strongly correlated between each other.
Right, exactly. So this goes into covariance. If I have two variables that are too related, too correlated, then I might not want to use both of them in my model because it's not adding any extra value. I really probably only need one of those two variables or multiple variables. So yeah, exactly. So it shows a little bit of the importance of the variable and then the relationship, and to also just show how this works with categorical.
Mm-hmm.
Um, then so I have a nova here, which is numerical versus categorical. So I'm looking at city fuel efficiency. I can sort this by data type, and let's go ahead and just grab all my string variables, which are my categories. I'll add that in here, hit OK. And now, because it is a categorical type, we're getting box plots. So this is showing my inner quartiles, my lower inner quartile, my higher inner quartile. It's showing outlier variable values with these points. This line is the 90% of the values, 10 percentile and 90 percentile values are between this line, and then 25 percentile to 75 percentile are between the box. And so we're seeing that most of the vehicles in this data set are continuous variable in their transmission, and the continuous variable transmission vehicles have higher city fuel efficiency. And then we're seeing the automated manual have lower fuel efficiency. I thought it was also interesting when I looked at manufacturer, we see things like Lamborghinis, which have low city fuel efficiency. And then you see things like Hondas, which across their whole manufacturing line have better fuel efficiency. So it's another way to look at these variables.
Yeah, and it's great to see box plots, of course. You've shown us a few things here buried in your dashboards around histograms and frequency charts, box plots, your correlation plots, scatter plots, all very, very standard techniques for exploring data, looking at each individual variable or pairs of variables. So all of these made pretty straightforward.
Yeah. And I wanted to show one more thing. I'm going to switch this a couple different quick examples. So now what I do with Spotfire when I start looking at a data set is I typically start with that data relationships tool, which looks at all of the relationships in the variables, and then I kind of explore that way. But another thing I often do is I look at these kind of AI recommendations, which finds relationships in the data.
Awesome.
As well. So you select a target variable, something that you're interested in understanding more about, and it will find relationships with the top predictors for this variable. So, we saw highway fuel efficiency earlier. I can actually just click this and add this in. This is highway fuel efficiency is really related to city fuel efficiency. Let's say I'm trying to make a more efficient vehicle, and I want to first understand what are the variables I should be concerned about. So I'm adding, drive description here, engine displacement. I'm adding a few of these cylinders in here. And so a lot of what we kind of expected to see, again, with the higher number of cylinders being, lower on city fuel efficiency, we see two-wheel front wheel drive vehicles having higher fuel efficiency there. But then I can also I can go into my color properties and I can select, let's say, let me put this on my city fuel efficiency. Oops. I can easily find outliers as well with just a quick color theme. So this is a built-in color theme that's going to build a rule for the greater than the upper inner fence and lower inner fence. And so I'm just finding the outlier values there. So those are some things I look at when I'm trying to understand my distributions. Now, I wanted to show a couple other quick examples of how this can be kind of used in more complete analysis. So this was analysis we were looking at life expectancy data across different countries, and we had tons of variables, and it was time series. It was done over many years. I think it was about like 10 years or so. And all these white areas you can see are missing values. These are null values in my data set. And so how do I handle null values? I don't necessarily need to leave these as null values when I go into my modeling. I may want to leave them as null and exclude them, but I also may be able to fill in some of these values. And there's a lot of sophisticated ways to do that. I use a pretty simple way here, which is I used a splined interpolation and a linear interpolation. And you can see for a certain variable, what I'm looking at here are these are all different countries. The blue line is the raw data. And so
So
where you see this
these are time series variables, basically, right?
exactly. And what you're seeing with this gap, so this is the time series right here, Stephen,
Yeah, there you
is
go.
yeah. So you're seeing over time, physicians per thousand people for each country, and this gap is where there was no raw data, and I can compare my spline, which is the red line, and my linear, which is the yellow line, and see well which one is interpolating better. And I felt the spline was interpolating better. So I applied a spline interpolation on my data set where I'm missing values. And as a comparison, this is the interpolated data, and this is a raw data. So you'll
Ah,
see certain values filled in here. Mhm. So you see certain values filled in here that we're missing here. Now, not everything could be interpolated because
there's
there
just
were
nothing to interpolate
there's
from.
nothing to interpolate. There is for that country in that year, or that country in that time frame, there was no data or only one data point, so nothing could be interpolated. But a lot more of this could be filled out.
Yeah.
And I think it's also useful using again like heat maps and stuff to look at the holes in the data.
So Neil, we've covered sort of categorical variables that you've looked at and also the data relationships between them, numerical variables, looking at distributions, looking at relationships. We looked at a little bit at time series. You mentioned about null data and null values, which we'll come back to again and again because it's such an important topic. What about like another other data types, geospatial data?
Yeah, it's good. It's a good point. There's a lot of different data types to work with, and different approaches depending on the data type. Um, and one thing also in terms of different approaches is here in Spotfire, I did a spline and linear interpolation, but there's also hierarchical clustering where you can select certain columns and rows, and what this is going to do is um, it's actually going to look at the nearby points and start to fill in all of these gaps in the data. So that's another built-in way
Mm,
you can fill this in. So it might use a k-means. It might use there's Euclidean method. There's correlation. There's all kinds of different distance measures, and it's going to look at the distance of the existing nearby points, and it can replace the empty value with certain row interpolation and column interpolation methods. Another thing we've done is with spatial data, going to different data types. Well, real quickly before going to spatial data, this is actually temporal data. I'm looking at river quality and in Scotland, and this is looking at let's see here. So this is looking at three different pollutants on the river, and let me line these up. So these are on the left. You have the raw data. On the right, you have some imputed data, and this is using the mice package, in R, and that's a multivariate imputation by chained equations. And then what this is doing is actually it's a more sophisticated way of trying to generate extra points and fill in some of the data. So you can see this like spike that it actually generated in here, which wasn't really in the data, and that's what that method's doing. Um, but then with the spatial data is so here is the let me zoom out here. This is the actual river network, and you can see these circles are my measuring stations,
mm,
and then these lines are my geometries.
mm.
And so I don't actually have a measuring station throughout my entire river network. There's only a few here and here. I'm not sure if you can really see these. There's only a few. And so what I wanted to, and then my rivers are these lines. And so these are single rows in Spotfire. They're one record. And so, or in the spatial data. So I want to be able to actually find something more granular. So I used a R script to actually extract vertices and points all along the river. So these gray points you see are actually generated by using a data function R in Spotfire to extract the vertices. And then what I'm able to do is then impute across, you can see these different 1, 2, 3, 4, 5, 6, 7, 8. There's different measuring stations all along this river.
Hmm.
And I've been able to actually impute the, let me go ahead and move here, what the pollutants look like across the river,
I see.
like that gradient looks like. So this is a way for me to enrich my existing data,
Mhm.
not just not just fill in null values, but actually create more granularity in my data so I can do better analyses.
That's great. Thanks, Neil. So there's, I mean, you covered a lot of things there, and there's a lot of power for dealing with different data types. And in contrast, I think, honestly, to what we saw with Python, where you really have to be aware of what libraries you need to use, of course, how to code in Python just in the first place. And here you can not just get going with all of the basic exploration type functions, but actually do some pretty advanced stuff in a pretty intuitive way. So that's very powerful.
Yeah, definitely. Yeah, and I think just to kind of reemphasize your earlier points, why I really like this is there's no coding really required. It's just a bunch of clicks. I'm starting to use, looking at a table of data can be very overwhelming.
Yeah.
But when you start to see the distributions and the shapes of the data, you start to get a better understanding of what's happening. And it can be a lot of fun to play with that and understand that before you start doing a lot of work with the modeling side and the feature engineering.
Well, I'm going back to the beginning of this project, and when we had the first few wafer map data sets given to us, we had one of our interns, Adam, actually, who now works for us full time, and he's going to be joining us in an upcoming session to talk about some of the work that he did. He spent a ton of time as an intern exploring these data sets and coming up with some pretty interesting insights. At one point, I think he went through almost every wafer map, and that was actually one of the reasons why we started looking at approaches like clustering data in order to have a more efficient way of looking at the different types of patterns. So we learned so much just from that initial exploration that Adam did. It's really guided the entire rest of the project that we're outlining in these Doctor Data Science sessions. So coming back to that point, actually, once we had sort of filled in our null values and we had pivoted the data and then visualized these, again, what Adam was finding was that there were these common patterns. We knew that from this industry. This is a well-known phenomenon that you have within the manufacturing process, certain hotspots or weak points or whatever it might be that yield these rings or these splotches, these donuts. And those are really the things that we want to drill into. So in our next session on data science, we're going to look at how we transformed the data in order to understand these patterns and begin to narrow down the patterns of interest. What we did as part of our exploration was use clustering techniques on the transformed data. And immediately we could see that certain types of patterns occurred over and over again. The big red spot, Adam gave them cute names, the plaid pattern, the big blob, and so on. And so we said, this is really now where the analysis really needs to focus, because ultimately, again, our goal is to find problematic wafers. So if we can cluster those into these types of patterns, then we can begin to model on those and track them down. Now, it's important then to be able to cluster very accurately, because you don't want outliers not showing up, because that is the entire point of the project, is to find those outliers, those unusual patterns. So we started off with these very standard clustering techniques to do the sort of thing that a human by him or herself wouldn't be able to do. We see these patterns emerge, but then immediately through our exploration, we realized that we have these problems with null values. These patterns are very radial in nature, and clustering tends to be sort of more tabular and square in some sense. Rotation is important, and clustering won't take that into account. Also performance. We've got thousands of wafers with 1,000 parameters. You've got millions of observations. To do clustering on that while taking care of the null values and doing very accurate clustering, we've got all sorts of issues that we need to resolve. So how do we improve the quality of the clusters? How do we deal with these null values? How do we model and cluster on such a large data set? The trick, as always, in data science, it seems to me, is to focus on being smart about transforming the data and generating features. And that's what we're going to talk about in our next session. Some pretty clever transforms that we did on the data in order to be able to do clustering and modeling more accurately. So tune in next month to discover what the next stage of the project was. Neil, thank you so much for joining us today. That was a lot of fun to explore data. As you say, it's in some ways often the most fun part of the project, right?
Yeah, yeah, it definitely is. Thanks for having me, Stephen. It was a great
Yeah, you
session.
bet. So join us next month. We're talking about features and transformations. Thanks everybody for joining us.